Hello and welcome to the channel. Today, I'd like to begin a deep dive into cicd, what it is, what it matters, and how to use it effectively in a real DevOps environment. This video will be especially helpful and insightful for any engineers like DevOps, QA professionals, project managers, and anyone who touches this topic in their work. It will be a detailed and slightly longer, so I recommend taking a cup of coffee, but I promise it will be worth your time. This is a unique, practical breakdown, and many people have already thanked me for making it clear and actionable. Before we proceed, if you find this content helpful, please like and subscribe. Your support helps grow our community and signals to YouTube that this channel provides valuable information. I very appreciate your help in sharing knowledge. First of all, let's start with the basics. cicd is one of the most important ideas I associated with DevOps. You often see the abbreviation cicd, but technically it includes three main parts. CI stands for continuous integration. The first CD usually means continuous delivery, and the second CD can also stand for continuous deployment. These three concepts are related but not the same. And it's very important to understand what each one means before you build a real CI/CD process. So, let's begin with continuous integration. This step focuses on code and mainly concerns the developers and how they write, test, and share their work. A key part of CI is integration changes into the main codebase regularly, several times a day if, of course, possible. Developers typically work in feature branches or follow workflow like Git flow or trunk-based development or whatever. But every change should be tested automatically before it's matched. The CI pipeline usually starts when a developer commits code to a shared repository. At that moment, several automated actions are triggered. Unit tests run, the code is compiled or built, and a static analysis tool might check for quality or security issues. One popular tool for checking code quality is, for example, SonarQube. It can analyze things like code style, complexity, and known vulnerabilities. These checks help identify problems early, which is much cheaper and safer than discovering them later in production. Are you agree with me? If any of the checks fail, the developer gets feedback immediately and can fix the problem before it spreads. In some companies, a failed test or low quality score will block the developer from merging the code into the main branch. This prevents unstable or unsafe changes from reaching production. It's also common to require manual code review or pull request approval at this stage. But the details of how your team designs the CI pipeline depends on how your developers work and what kind of quality standards you want to enforce. Once a change passes all checks and is approved, it can be merged. From here, we move to the next phase, continuous delivery. So everything related to code belongs to continuous integration. Continuous delivery starts after the CI step is finished. At this point, your code is built, tested, and approved. The goal of continuous delivery is to prepare and package this code so it can be safely and quickly deployed to different environments, including production. Artifacts are generated. This could be a Docker image or compiled binary like a jar file or any other deployable output. These artifacts should not be changed after they are built. They are versioned and stored in an artifact repository ready to be deployed, like, for example, Nexus or S3 Market. These packages are then tested again. This could be manual testing, automated regression testing, API testing, or any other types of quality checks, depending on your organization's setup. The important idea is that the exact same package is tested and then deployed across all environments from staging to production. This guarantees consistency. If you test one version and deploy a different version later, your tests don't really mean anything. Now, here's a key point. In case of continuous delivery, deployment to production is usually a manual decision. Everything up to production is automated, but the final deployment needs human approval. This is very important in environments where extra caution is needed, like finance, healthcare, enterprise systems, etc., etc. Now, let's talk about the next step in case of continuous deployment. It's completely similar to continuous delivery, but with one critical difference. Deployment to production is fully automated. As soon as change passes all tests and quality checks, it's immediately released to users. This is no manual approval. This approach can be very powerful, especially in large-scale systems, where updates happen frequently and rollback procedures are reliable. But it also requires a high level of confidentiality in your pipelines, your tests, and your observability. You need strong monitoring, logging, alerting, and rollback plans ready. Security scanning and secret management also become very crucial. Automated deployment leaves little room for mistakes. You may sometimes see cicd described as if it includes everything, from code commit to production. But in my experience, it's more accurate to separate CI, CD delivery, and CD deployment into distinct phases. Each of them has different responsibilities and benefits. You must decide with your team which phases you need, how to implement them, and how much automation is appropriate. Let's also highlight common CI/CD pitfalls, because knowing what not to do is just as important. A frequent mistake is building artifacts multiple times across environments, which breaks consistency. Another issue is weak test coverage. When teams skip writing or automation enough tests, it leads to instability. CI/CD is not just about pushing code quickly. It's about pushing the right code reliably and, the most important, safely. Now let's quickly cover the code principles behind CI/CD. The first principle is divide responsibility clearly across stages. Each step in the process should be responsible for something specific and should detect and fix issues early. For example, if a code problem is found during unit testing, it should be fixed before the code moves to later stages like deployment. Otherwise, errors accumulate and get harder to debug. The second principle is short feedback loops. Every step in the pipeline should provide fast and clear feedback. This helps developers and testers react quickly. It also reduces the risk of broken code reaching production. Good pipelines run in small iterations, and they test code in the same environment where the software will eventually run. Security is another core principle. In modern pipelines, security testing must be integrated early. Tools like Snake, Travi, or SonarQube help detect vulnerabilities and dependencies or container images. Secure secrets management with tools like Vault or environment-specific controls is essential to avoid accidental exposure. Finally, we built all of this for a reason. CI/CD is not just about automation. It brings real business value. When CI/CD is set up correctly, all teams, developer, QA, product managers, delivery managers, etc., share a single unified view of how the product moves through its life cycle. Everyone sees the same build, test, and release stages. This reduces confusion and increasing trust in the process. When everything is automated and consistent, deployment becomes safer and faster. You reduce delays, improve code quality, and make it easier to deliver new features to users. You can even run A/B tests or canary deployment, releasing new features to a small group of users before a full rollout. This lowers risk and increases learning. For example, one large e-commerce platform improved the time to market by over 40% simply by replacing manual QA handoffs with parallel automated testing and continuous delivery. So, CI is about source code, continuous delivery, and continuous deployment are about similar steps in your CI/CD pipeline, but in case of CD, continuous delivery, deployment to production is automated, and in case of CD, continuous delivery, deployment to production is fully automated. This is main difference between these steps in your CI/CD pipelines. Thank you for watching and see you in the next videos.